Hello everyone, my name is Jeshnu and today I'm going to talk about Facebook Distributed System case study and author Asma Mohammed Salem. Today I'm going to talk about how communication happens in Facebook, how people at different places can talk to each other, how the data centers at different locations are connected, how the Facebook is distributed around the world. Facebook was introduced in 2004 with a mission to connect people. Um, it is inspired by Hadoop and Hive. Hadoop and Hive is a company which started to resolve the database problems. Instead of following the regular series communication, they started to follow the parallel processing uh, implementation. And the main problem was where to store the data and how to store the data where when there's huge traffic of data flow every day. It's estimated as 125 terabytes of data is stored in the data centers each day. So to solve this problem, the Hadoop and Hive system started a new technology, a new way is that is parallel processing instead of the regular series processing. They are responsible for large data processing named big data. They have this big data centers around the world, one in California, one new just 2 years old in Texas, and many around the world. Facebook is the leader of the online social network right now. Facebook has around 2 billion follow friends, 2 billion people using yeah, the application right now. It is the number one in the online social network. Uh, yeah. So let's talk about Facebook. In the distributed system features, Facebook these are the following features which come under Facebook. The first one is wall. A wall is a place where you post photos, videos, or share any content you like, or any videos you like, or any pictures you want to share it with your friends, or any news you want to tell to anyone. And the next is newsfeed. The newsfeed is where you get the news or any story or any notification, any update from your friends, and it is like a homepage. This is an example newsfeed homepage of Facebook, and this is like the homepage, and this is the newsfeed, and here you have the ads, advertisements, and here you have the list of friends whom you can talk to, or the notifications of people who have liked your photo or maybe commented or maybe shared one of your videos. And this is the place where you can see your notifications, your ad requests, and the message. And this is a this is a home page of any person. If you want to see details of a person, if you want to see about your friend, like what is he up to, what is he doing, where is he studying, or any such information, you can know it all in this place. You can see the profile picture of the person, uh, his last post, where did he study, his friends, his likes, dislikes, his friends, and all the things over here. And what Zuckerberg created here is he created a web application where people could talk and be connected to their parents across the world without even staying with them. People could know about them, know their health details, or any new updates in their life or anything without even going there, without even having to meet them in person. He created an online community where people could communicate, talk to each other, and know about them, and uh, live uh, live with each other. And you can also like photos, comment on photos, tag your friends, tag friends in your photos, share these photos, and all the things you do, you like, share, and everything is a request going to the server. It's like a process or a request which is sent to the data center to process it, and the output is sent back to the system, and the output is seen. Like if you want to like a photo and the photo is liked, and this is all created by Hadoop and Hive systems, and they are the one of the leading IT leading company in the tech IT industry. And it's also said that by it is predicted that by 2020, 75% of the top 500 Fortune companies would be using Hadoop and Hive systems for data storage facilities. Now, when we look at the OSN traffic patterns, OSN online social network traffic patterns of Facebook, the when you in when while using the Facebook, every like, every share, every comment, every request, everything is a request going to the server. And the more and more likes you people, more and more people like, or more and more people comment, the traffic is increased. So the more and more increase in Facebook users, the OSN traffic has had a drastic increase in the recent years. Since December 2004, when Facebook has been started, it has increased uh, gradually, and since 2009, there was a major rise in the OSN traffic patterns, and people started using Facebook all over the world, and people across uh, uh, all the parts of the world started talking, sharing things, and communicating, and soon Facebook was one of the leading OSN network company. Soon, the traffic increased furthermore with the applications like games and websites, interactive websites through Facebook, all the messages and chat services, and all the multimedia you post, and everything uh, affects your traffic patterns. So with this increase in traffic patterns, the major issue which comes to the problem is data centers. Where do you store the data? Where the data, yeah, how the data is processed, and how the data which is stored at different parts of the world is processed, and within very less time, how can it be processed and shown on the screen? And to resolve that, instead of following the right schema, read schema has been followed in the Hadoop Hive system. Uh, this is a distributed system, a Facebook distributed system in California. Uh, a distributed system data center is basically divided into three categories. The first category, in the first, the web applications and the web process are taking place, and in the second section, the communication and where the messages are transferred, the processing, and all the web applications are stored. And in the third tier, the storage, the data centers, the client request data, all the data processing is done in the third category. Facebook being one of the biggest online social network, they rely on globally distributed data centers. They have their data centers distributed across all around the world, and their main focus and their main priority is on scalability and reliability instead of performance. What regular applications, what every application, data center application does is they prioritize performance over scalability and reliability. When a client requests data at the data center, instead of storing the data at a single location, the data is broken down into blocks, smaller blocks, and stored at different locations, and it is replicated minimum 3 times. And so uh, storing at one place to achieve the fault tolerance in the Facebook distributed system. So scalability and reliability are the priority for Hadoop and Hive systems instead of the performance. And the stages of distributed system request. First, all the likes or the share or any uh, comment or post you do is a request, and the request is the created request is sent to a web server, and the web server divides the data into small blocks and sends the task manager at the web server uh, locates the distributes the blocks at different locations and stores them at different locations. And after that, then the data is then sent to Scribe Hadoop cluster, where the data is whenever the client wants any data back, or whenever they want to see the message, or whenever they want to get the message back, the Scribe Hadoop cluster relocates the data and brings the data back. And Hive Hadoop servers is a system created over Hadoop servers, and it is used to decrease the fault tolerance. And what they created is they created many number of uh, master servers, so that even when one server crash, there is no data loss and there's no fault tolerance. And the distributed system in Hadoop Hive follow a master slave architecture. Uh, Client requests, all the likes, shares, and comments, and all the posts are the client requests. Requests are stored in data nodes, and these data nodes are located at different locations in the data centers. And each data is divided into blocks, and those blocks are stored in these data nodes. And different data nodes are located at different locations. And Facebook maintains data centers in Santa Clara, San Francisco, and Northern Virginia, and many such locations. And a data center, this is a typical data center in Facebook. It is estimated that approximately 250 terabytes of data is stored a day. It's said that every day so many terabytes and picobytes of data is stored in a day. Facebook maintains these data centers in many locations in San Francisco, Texas, and Virginia. And it basically has a uh, three-tier architecture, where the tier one has the web services, all the web services, web applications, the games, pages, web services are all done through Java or any language, and all those are processed in the tier one. And then tier two is where the processing of the data takes place, and the messages sent, the addresses, and the communication between the data centers is taking place. And the main uh, tier, the third tier, has the web servers, The web servers store the data. This is where the data is stored in blocks, in form of blocks, and each all the data is broken into small blocks and stored in different locations, and all kinds of data like the address of the message, the information of the message, the connection, and everything is stored in uh, the data centers. And these data centers are connected with different data centers in different locations with TCP communication, where with TCP implementation, with HTTP request message sent. And then the message is sent to Scribe Hadoop a cluster where the data is brought back together, where the data is processed, and they follow write read schema instead of write schema, because when you follow the right schema, both the data centers should know the data center should know the information about the the receiving data center, but what kind of tables do they want, or what kind of data language do they use. But in the case of uh, in the case of a read schema, the data, you don't need to know the language, you don't need to know the location, and the data with the read schema, it's read once and write once, and write once read many system, where you write once and you read at every location. So you read the message, and the message is then read the message and then assemble the blocks and form a readable message back, and for bring it back to the original state, and then pass it to the Hive Hadoop cluster. And in the Hive Hadoop cluster, this is basically divided into two categories: the production and ad hoc. This cluster is basically made over Hadoop cluster. It is a fault-tolerant cluster where a cluster is basically a group of servers. It could be around hundreds to thousands of servers, hundreds of servers, or maybe thousands of servers. So they create a fault tolerance cluster. So what they create is they create not just one but many parent servers. So even if one parent server crashed because of any external factor, the message would not fail. The message would not wait to pass, because the message would leave with, because it can access through any other server. So they create a fault tolerant cluster by creating many number of parent clusters. And all these clusters are divided based on the priority of the jobs and based on the priority of the requests. If and Because Facebook follows the series schema, um, at one time different process can run at the same time. You can text a person and while scrolling through your wall, or while watching video. You could even comment on anybody's message. So this could be possible with the series schema. And this could be possible because uh, they prioritize more on scalability and availability than the performance. And distributed system component, uh, every terabyte and petabytes of data is every day in Hadoop, around terabytes to petabytes of data is processed. To achieve the scalability and reliability, Facebook uses Hadoop. It's still using Hadoop. It follows parallel processing, where the requests are processed parallelly. Each type of request is divided into blocks. Like if you try to like all the like requests go to one block, and all the comment requests go to one block. So all the processes are parallelly processed, and whichever is done first would be the output would be produced first. So this helped in helped to achieve scalability and reliability, and this helped to process terabytes and petabytes of data each day. What is Hadoop? Hadoop is a software framework for distributed processing of large data sets across large clusters of computers. So basically, Hadoop is a software where it creates data sets around different parts of the world, where different large clusters, which means n number of servers are located, and they communicate with each other using parallel processing, and with this they achieve scalability and reliability. So large data sets mean terabytes of data, large clusters, so thousands and hundreds and thousands of nodes. And Hadoop is an open source implementation, and it basically has two parts: Hadoop Distributed File System (HDFS) and MapReduce. It is divided into mainly divided into these two parts, and each part has a parent. Uh, each part has a parent node and a child node. So how Hadoop works? Hadoop follows master-slave architecture to process the data. So this is the master node, which is the name node, and these are the slave nodes. So what Hadoop does is it creates many master nodes, and each master node would have slave nodes. And then the task of master node is to tell the slave node the task to do. So each slave node has a data node where the data is stored, the IP address, the messages, and the data link, and everything is stored in the data node. The task tracker job is to make the get the gather save the store the information in data node, or whenever map a different location whenever needed, or reduce it to a message whenever needed, and also keep updating the information of a task to the job tracker. And the name node is master node, and data node stores data to process in the slave node. Hadoop distributed the first part of Hadoop is Hadoop Distributed File System (HDFS). It is a low cost hardware system for high fault tolerance. So what they created is they used these cheap low cost systems, and took n number of those data systems and created cluster of servers, and stored more and more amount of data by dividing them into blocks and saving the data in data storage. It maintains the data in form of metadata, and it stores about 64 MB of data in each block. The request files are stored in files which are divided into blocks, and each data block is replicated n times and stored in different blocks. And it's the minimum is 3, and it's minimum replicated 3 times. And when a client requests data, once the data is written, the message is sent to the name block, and the name block assigns the data to the data node, and the data is stored in different data nodes in a data pipeline. Each request is divided into blocks, and each block is stored at different data nodes, and all the blocks are received to the name node, whenever the client requests it to process. And this is a HDFS architecture. This is the name node, and this is the data node. When a client writes the data, the he writes the data, and the data is stored at different data nodes, and it is replicated at least 3 times and maybe more, depending upon the each application, to avoid fault, to achieve high fault tolerance. And the metadata, it is stored in form of metadata, uh, in and whenever the client wants the information, it is read, and the name node gets the information, the data. And the second part of Hadoop architecture is the MapReduce. When MapReduce, it is basically divided into two categories: map and reduce. The once the data is stored in the database, let's say you wanted to like you liked a photo or commented on a photo, so that data is stored in using the HDFS in your system. And after it being stored, when you close the flows Facebook, or you open it again, and you want to see the post you posted back. So to get the data back on your screen, to they use this tool MapReduce. And it has two types. It is divided into two categories: map and reduce. And job tracker assigns the job to the task tracker, and this follows a master slave architecture. So when a client program submits a job, it gives a job, it's the task of the job tracker to give tasks to the task manager, give job to the task manager, task tracker, to the information about the location, the data, or where the data has to be stored, the key of the data, and and this is the map phase, where the data is mapped at different locations. When there's an input file entering the system, it is split, like it can be seen here, in split into 5 parts, and each part is stored at different task tracker. This is task tracker 1, 2, and 3. And different at different task trackers, the input file is split and stored, and they are mapped and saved, and the location of the data is stored at the task tracker. And the tracker keeps getting the updates from task tracker about the location and information of the client process. And when in the reduce phase, when the message has to be popped up on the screen, the it is once again the task of the job tracker to tell the task tracker to uh, get the information of in the message and the location. And uh, and it is reduced back to the original state. And it is once the message is received, and it follows the read schema. And the read schema reads the message and sorts the message, and then reduces it to the original state of the message, and then the output is sent to the screen. And it follows a master slave architecture. Hence it is always the job tracker is always updated about the information of the message. And this is an example of user request. When this is the input, and when the message is entered into an MapReduce system, it is split into 3 parts. And all the this is the first, this is second, this is the third message, and then it is mapped into different locations. This is mapped into the Now this system is 3 map and 4 reduce system, where it is mapped to different locations, and all the bear are saved at one place, and all the car are saved at one place, and all the deers are saved at one place, and all the river information of river are saved at one place. And when this is message has to be used, this is then reduced to back to one single message, and this is sorted in the final stage and popped on screen, and then final result is achieved. Hadoop Hive, as discussed earlier, is a system created over the Hadoop system. It is used to achieve the high fault tolerance. Hive is a data warehouse infrastructure built on top of Hadoop technology. And let's come to the communication. And this is how, until here we have discussed how the data is stored in the Facebook. And let's come talk about communication. The connection is made between different parts of the world through data centers, and it is connected. And all these data centers are connected by establishing a TCP connection with server and receive a HTML response back. And these data centers are geographically placed at different parts of the world to control the heavy traffic. So, and each data center and all the data centers rely on the solution to maintain the network reliability and the system availability. The solution was CDN, Content Delivery Network. The problem was when you store message at different locations, when you want a message from, let's say, in Australia to be passed to a message to be seen in a server in a screen in America. So to pass this message from this long would take a lot of time, and there's a problem of data loss and lots of issues. So to solve this problem, to maintain the network reliability and the system availability, this solution was CDN, the Content Delivery Network. Mm, yeah, this is the communication, Facebook communication using the TCP proxies. So what did they do is over here is this is the user, and this is a server in California, and this is the user. So to communicate, instead of connecting this is a usual TCP connection. So with the usual TCP connection, you have to connect to the server, and the messages takes at least 4 steps, and then the message is passed, message is received. And so to resolve this problem, Facebook communication, this is Facebook communication using OSN cache. So in this, the user does not need to communicate with uh, the data center to achieve to achieve the final message. It can get the message from the CDN server, which is located near them. So this is how they achieve the uh, system reliability. And with the increase in data centers and with the increase in users of Facebook, cloud computing has increased in web applications and web uh, users. To create Facebook as a virtual machine, the cloud computing has started using the load balancer, and the users started using the cloud to use web applications and use the cloud computing to interact with people around the world, and use web applications for games and interacting websites. So the communication is established with the TCP network, and with the introduction of with the increase in demand of cloud computing, with the increase in development of cloud computing, people started developing web applications and web apps using cloud computing support, where they create a web application using the virtual machine and the load balancer. The user could use the load balancer, and this would use the root and decrease the load, and a database in the virtual machine would store the data and quickly send pop the message on the screen, decreasing the load on the system. And this is a scaling algorithm which has to be given by the user, and the scaling algorithm is the service monitor subsystem uses the scaling algorithm and the provision subsystem. And now concluding today, we've covered about the system availability and reliability, which is achieved by TCP communication between the servers, and the scalability, which is achieved by different data centers, and the CDN TCP proxy servers, which are used in communication, and cloud computing integration, which is developing in web applications and creating web applications for games and many such users. Thank you.